Students are sometimes surprised to see that we need more than 3 variables in a problem, simply because we get used to the idea of x, y, and z. And I hope through this example here in the finance world that you can see that having functions of 4, 5, 10 variables is easy to arrange. It just depends on how many inputs you're willing to consider having an effect on some variable, output variable of interest. One example would be if we look at how much you'd have to pay in dollars per month on a mortgage. That's going to be a factor of several inputs. 1, how much do you borrow? 2, what percentage rate are you borrowing at? And 3, what's the amortization period, or how long is it going to take you to pay back the loan? Now that's the most basic model. This is assuming a fixed rate for the entire amortization. And if that's the case, that's the minimum 3 variables that we would need to define or to calculate the monthly payments on a mortgage. We could potentially talk about interest rates changing over time, and then you'd have a whole host of variables. What's the interest rate a year from now, 2 years from now? For now, let's focus on the kinds of comments we can say about this relationship, that our monthly payments are a function or depends on our amount borrowed, the interest rate, and the amortization period. Can we identify some simple relationships between the monthly payment and these variables? I think it's pretty clear that if we increase our amount borrowed, we certainly increase the payments. Interest rate, if we increase R, then we definitely increase the payments as well. Again, this is always assuming the other variables are kept constant. That's important because, as we'll explore in a second, it's possible to trade things off one against the other, but it's not necessarily the increasing or decreasing relationships we talk about. We talk about when the other variables are kept constant and we just change the amount borrowed, we just change the interest rate. The last one of these variables that we're considering for now is that we repay over t years. So a longer time frame, if we have a longer time to pay back the same amount at the same interest, that will cause a decrease in the monthly payments. Now, what people who are interested in mortgages or car loans or anything else might want to consider is that we can trade off some of these variables. And one classic example of this is to increase A, the amount borrowed, and also increase T, the time to repay. And if you balance those correctly, you can keep P constant. So when we talk about P being an increasing function of these inputs, that's a simple relationship, assuming the other variables are kept constant. The trade-offs that we might make would be how the variables interrelate to one another. Just as a final thing on this example, let's interpret some statements about this. Order matters when we define a function like this. It's A, R, and T. That's how we defined it on the previous page. So if we had this f of A, R, and T is approximately this value here, in English this would be for a loan or mortgage of $250,000 at 4% interest, annual interest, and to be repaid over 10 years, the monthly payments will be, or would need to be, approximately $2,500. per month. So that kind of statement clearly shows how we have a function of three inputs in this case, amount, rate, and time to repay, and it produces a single output. Okay, how much do I have to pay per month? If we change the inputs, we get a new output. And the domain here, we could talk about that as well. Any positive amount, any positive interest rate, and any positive amount of repayment time would make sense. So that's another way we can introduce functions of multiple variables in a financial context.